Hello everyone. Hello everyone. I hope you are doing very well. My name is Mohamed Lamid. I'm from class TI 23 in informatics. Here is my slide presentation for my journal. The title is Predicting Students' Performances Using Machine Learning, Key Mean Clustering. Introduction. The context. Academic is success. Academic success is vital for educational institutions, but traditional identification of struggling students is often reactive and deploy. So the opportunities. What's the opportunity that we are getting from? It's just to know large educational data set and advanced machine learning techniques allow for a proactive students and allow also to predict with approach and support students. So the goal, leverage data mining to gain deeper insight into student performances patterns for timely personalized intervention. So the problem statement and objective of this research, we have challenge. Educational institutions lack a robust data-driven system that can both group students into meaningful segments and accurately predict their future academic performance. The first problem is segmentation. Segment the student's body into distinct, actionable performance and risk group using unsupervised learning. We have second, we have prediction. Accurately predict final academic performance based on early students' attribute using supervised learning. Third, actionable insight. Provide data informed insight, inform educational intervention, strategies, and policy. Research methodology. We have here quantitative, a two-pronged approach that I use here is supervised and unsupervised machine learning techniques for comprehensive analysis. For unsupervised learning, K-mean clustering is employed to discover hidden patterns and segment students into natural performance group. Supervised learning, I use gradient boosting (GB) regression to build a robust model for accurately forecasting academic outcomes. So the data that I got is from Kaggle, more than 1,000 data that I compile. We have data pre-processing and feature engineering. After collecting the data, so we proceed to data cleaning, and then after data cleaning, data visualization, and interpretation, so and get like the result. For data cleaning, validation, the outright Kaggle dataset confirmed zero missing value of duplicate record, ensuring high data quality. Feature engineering is create average score as the target variables calculated as the mean of math, reading, and written scores. Categorical encoding apply one hot encoding for nominal variable and ordinal encoding for ranked features. Feature scaling is given standardization was applied to all numerical features to ensure equal contribution to distance-based models. Then we have exploratory data analysis (EDA) highlight. We have score nominality, key performance indicator, inter-subject synergy. Student segmentation using main clustering, and here as you are seeing, like the image from the image is the example of how we cluster the data. Clustering methodology, common learning or supervised learning, was used to partition the student population into distinct, non-overlapping subgroup based on performance profile. We have here that data is before came in, before clustering. After clustering, we got different groups. Optimal cluster with k equals 3 is to determine via Hilbert method and silver score identifying three actionable performance and risk group. And here as well is before come in and there is after come in. So we are done with unsupervised learning, clustering. So right now we started with supervised learning. XGBoost. Extreme gradient boosting was selected for its efficiency and superior performance in structured data prediction tasks, sequentially combining weak learners to build a robust model. So with GB Booster is to collect like all the weak group students and start combine them to build robust model. Okay, here is the model development. We have 70% training that is split with just 30% testing. Optimization, get session turning, and here validation and target. So if we see here hypermeter turn and estimation, learning rate, max deep, subsample, and call sample. So here is the role of GB Booster. Combine all the weak students groups and build them and try to build a robust model. What is the result from the data set that we collect and we use supervised and unsupervised learning? Okay, for clustering success, the Kamin algorithm successfully partitioned the students' population into three distinct actionable groups. So for the first one with unsupervised learning, we divided with high achieving students with low risks, and second, average mid-range with moderate risks. The third group one is low performing with risk. So the prediction accuracy is 1.31, with R square is 0.99. I mean, yes, like a strong, you have strong connection. So the risks has the impact, can impact the result of students. Conclusion. So to conclude, we can say a robust predictive framework. The integration of K-mean clustering and gradient boosting provide a powerful tool for early identification of at-risk students with high accuracy. So with R square that we got 0.9923 means is students with high risk. And this is the high accuracy result that we got. So the impact, educational institution can now move from reactive to proactive support, allocating resources specifically to identify risk, cluster based on key indicator like launch, type, and test preparation. So guys, here is the conclusion of our presentation. and thank you so much for your attention. If you have any question, don't hesitate to ask. You can drop it in the comment. Thank you so much. Bye bye.